So in class, we talked about that buffers, and remember, the job of a buffer is to maintain the pH when small amounts of acid or base are added to it. And to get a buffer to work, it has two components. It has a weak acid and that weak acid's conjugate base, so the partners. And what happens is when you add to a buffer small amounts of base, the weak acid neutralizes it. And if you add small amounts of acid, the conjugate base neutralizes it. So it has two components that will work together to maintain pH. It doesn't mean that the pH will be neutral at 7. The pH that's maintained depends on the weak acid and the ratio of acid and base. And in our class, we're not going to calculate that. We just need to know what the job of a buffer is and what it's made of. So this question gives us three combinations, and it wants to know if they could make a buffer. So I can tell you right away, C would not, right? It cannot be a buffer because you cannot have one thing alone. You have to have a weak acid and a conjugate base. And this is acetic acid, so it is a weak acid, but you cannot have it by itself. You have to have both components. So that's an easy, let's cross it out. Now, the second one, it says determine whether the solution contained, is a buffer. So what you have to know is this acid a weak acid? And so let's look, and you don't have to memorize these. These would be given to you, but here, this is a slide from a previous slide, and it has listed the common strong acids. And look who's there, HBr. Okay, so going back, this cannot be a buffer. Why? HBr is a strong acid. Now, if you weren't watching this video, you could look in your textbook. It has the strong acids. You could look on the presentation slides, the PowerPoint. I have that same slide. They have strong acids. I think on the exam table that I give you, I think I listed the strong acids and bases there. So there's several places. You don't have to memorize it. There's several places you could look to check it out. Okay, so now we have HF and KF. So let's go back and look. So I look at my strong acids and HF is not there. So HF here, it just happens to be there, but just not being here means it's a weak acid. So HF is a weak acid. Okay, so that's good. Now we need its conjugate base. So if you have HF, that's the acid, and what acids do is they donate their hydrogen, and that would make this F minus. This is a conjugate base. Now, here's the thing about chemicals. There is no chemical F minus. It's a fluoride ion. It doesn't exist just by itself. So where the fluoride ion comes into play is you have to have an ionic compound. Whoops, I don't know what happened. I hit something that did a weird thing. And ionic compounds, when they're dissolved in water, they dissociate. We talked about this before. So when you're in your buffer, KF will separate and make potassium ions and fluoride ions. And there you go. So this does have, it has the weak acid, and it has right there the F minus, the conjugate base. So that letter B is a buffer. Now, you wouldn't have to show that you split it apart, but if you could notice that it's a metal and a non-metal, then you could know they would split apart. So that F minus would come together to be the buffer. Okay, so that's how you have to look at when you have those type of compounds. Think about what it would do to dissociate to get that conjugate base.